Hi everyone. Today we're going to be talking a bit about GraphQL and the lessons that we've learned from implementing a GraphQL API. So my name is Dirk. It's my buddy Florentijn. I'm going to be presenting with him today. And we're really excited about GraphQL. We think it's an awesome technology and it gives us a lot of flexibility. And that's why we wanted to present it to you today. So first the question, who has read or heard about GraphQL? Basically everyone. Who's actually played around a bit with GraphQL and implemented something? Oh, it's quite a few. Nice, nice. So hopefully some new stuff for those people. And
actually, final question: who has a GraphQL API introduction?
Nice, cool guys. So a bit about us. My name is Dirk, and like I said, for a long time we're both software engineers working on the back end. We write predominantly in JavaScript, and we're working for a company called Hogerwerf, way in the south. And I don't know if you guys know the city Maastricht. It was a long train ride with all the delays. It was horrible, but we made it, so it's fine. And yeah, Hogerwerf aims to improve the customer experience in the insurance industry by using new technology. So one of our technologies is of course GraphQL that we're using. So a bit about the agenda of today. We're going to be talking about what GraphQL is, to give a little bit of an introduction. And why it's awesome, and then we're going to talk about some lessons that we've learned from implementing an API. So first, what is GraphQL? Well, in a single sentence, it's a query language for your API, and it has some nice properties. So the client is in control of the data that's retrieved from the API, and not the server. And this creates a lot of flexibility because you don't have the problem of overfetching data. Another key advantage is that you can get multiple resources in a single request, in contrast to or something like a REST API. The documentation is super awesome. We're going to show you a bit about how the documentation works in GraphQL, but it's really a first-class citizen, and we think it really helps you implement a GraphQL API when the documentation is this good. And it's a full type system for your API, so when you write a query to a GraphQL API, it performs automatic query validation, it gives you proper error messages, and it's just a really nice way to work. And you can also define things like objects, a bit like just any programming language, like classes. You can define objects, they have primitives like string, integers, and floats that you can use. So it's really nice in that way. And there's some really cool developer tools. So one of them is GraphQL. We're actually going to show it soon. And this is a really nice tool for actually testing out your GraphQL queries. So we've got a small demo set up to just show you how it works a bit for the people that are not really familiar with it. So in this demo, we've created a joke machine. So this is an API for basically retrieving jokes and doing all kinds of operational jokes. We've included some jokes, so be prepared to laugh like crazy. Okay, so this joke is really nice. Florentijn actually came up with it, so it's an original. We did not grab this from the internet.
Joke is a
So
font size?
sorry?
Joke is a font size?
Joke?
The font size.
Oh, sorry.
Readable.
Better like this?
Yep.
You guys read it now? Sorry. For me, it's super clear, of course, but So, so what we have here is a tool called GraphQL, and it's basically like an IDE environment for writing and validating your GraphQL queries, and you can test them out. And this is used a lot by our front-end people for writing the queries that they actually need to implement in the front-end, and it really helps you a lot. This tool, it provides you with handy error messages if you make a mistake. For example, it shows you the inline documentation. So you see on the bottom here that we've got the currently authenticated user that we're dealing with when we're requesting the viewer. And an awesome thing about GraphQL is that you can really build up your query. So the client is in control of the data that's retrieved and not the server. So currently we've got a query implemented on the left there where we're requesting the currently authenticated user. And then for this user, we're requesting one of his jokes for a certain ID. And then for the joke that we're retrieving, we're finding out the ID, the text, and the funny level. And so on the right here, we see the response. And the response mimics the fields that we're requesting on the left. So if you write your query, it's pretty obvious what the response is going to be in the JSON because the keys are very similar. A nice advantage about GraphQL is that it's, like I said, the client is in control of the data that's requested. So if the client thinks, oh, I don't want to know the funny level, you just delete it, rerun your query, and the funny level is gone, and you're not overfetching anything, and it's very flexible in that way. You don't need to make any changes to your server. A bit about the documentation that we talked about. When you're implementing an API, documentation is very important. It's not always the case that it's up to date with APIs, but in GraphQL, this is really nicely dealt with. So on the right here, we have a documentation explorer that basically shows you all the queries and mutations that you can make. So queries are used to actually retrieve data, and mutations are used to make changes to your database. So if we look here at the query that we can retrieve, we're currently looking at the viewer on the left, and that returns a user type. And the user type contains some fields like the ID, the name. You can get an array of jokes, or you can get a single joke or an ID. And you can see the types on the right and a description of what you're retrieving. So, super awesome. I hope you guys can see why we like it. And this is just a short introduction of how it works. We'd love to go into more of this, but we want to get to our lessons. So the first lesson, separation of concerns. So when you're building a GraphQL API, you're starting out by building it. How should you structure your code in the backend to keep it maintainable over time? So if we start very simple, we have this query that we want to implement, or we want to retrieve a joke for a certain ID. And for this joke, we want to retrieve the ID, the text, and the funny level. So how do we go about implementing this? Well, we've got an implementation here in JavaScript, but GraphQL can be implemented in any language, so you don't need to do it in JavaScript if you want. But here the joke is implemented as follows. We see here that it returns a GraphQL joke. That's the type field. It contains some arguments like the ID, which is of type GraphQL ID, and it must be non-null. So if you write a request where you don't add an ID, it will immediately give you an error. And on the bottom here we have a resolver function, and this resolver function is basically called whenever you do a query to GraphQL. So anytime a query is made for the joke, this resolver function is called, and it basically, when you implement it, you need to get the data that is requested. So here it's very simple. If we want to find the joke by an ID, we simply go to our database, we call find by ID, or whatever database you guys are using, doesn't matter, and then we pass in the args.id to retrieve the joke. But we're not really done yet. We also need to take into account authorization, so it's very painful for privacy if I'm retrieving someone else's jokes. We want to prevent this, and to do this, we need to add some authorization to our code. So to do this, we use the field here called context. This is the third parameter here. And the context is a data object that contains some contextual data about the request that's currently being passed into GraphQL. So it's very common for an authenticated API that you pass in the currently authenticated user inside the viewer property in this context. So we've implemented this here. So if we add authorization, what we first do is we retrieve a joke by its ID. If there's no joke for this ID, we simply return null. And then we have an authorization step where we say that a joke can only be seen by its creator. So what happens, we take the creator ID inside of the data coming from the database, and then we check if it's equal to the viewer's ID in the context. And if it's possible for this joke to be seen, then we return the data. Otherwise, we would just simply return null, because it doesn't exist for this user. What you see here is that we're returning a GraphQL joke, and this is an object type in GraphQL. So how do we go about implementing this? Well, we simply use a GraphQL object type for this. We implement the fields. So we say we have an ID, a text, and a funny level. These are all non-null, and an ID, string, and integer respectively. And again, here we see these resolver functions, and these resolver functions are used to give these fields actual data. So if we go back to the query that we've implemented here, you can see that we're returning some data there on the bottom. And this data is passed directly into the resolver functions of the type that's being returned. and then simply these resolver functions maps to the type, to the corresponding type in the data. It's very simple. So the result is a very funny joke. You guys like it? Good, right? All on the internet. The funny level is 0 for a reason here. Haha, I know. Nice. Next, suppose now we want to update a joke. That's good laughs, man. Childish humor here. Suppose now that we want to update a joke where we're passing a certain joke ID and we say this joke is so funny it must have a funny level 10. And then for this updated joke we want to retrieve the ID, the text, and the funny level. So quite a simple mutation. How would we go about implementing this? Well, quite similar to the query that we made. We say here that this mutation returns the type GraphQL joke. It's non-null in this case. There's a description there to say that this is an update to a joke. And then we pass in the arguments of the joke ID and the funny level, and we give them the appropriate type. And then again, we run into this resolve function. This resolve function basically tells you to implement some functionality to update the joke in the database. So how will we go about implementing this? Very simple. We perform some validation on the funny level that's passed in. So if it's not between 0 and 5, then it's invalid. You can't go beyond the funny level 5 because nothing is that funny. Then we simply request the data from the database, and if it doesn't exist in the database, we throw a new error that it doesn't exist. And then we perform some authorization, just like the authorization that we did for the query, to make sure that the person trying to change the data is actually the creator of the joke. And finally, we perform the update where we say that the funny level is equal to the new funny level. We save the data, and then we return the data. And one thing we can note here is that we've implemented exactly the same authorization logic in this resolver as the authorization logic that we implemented in the query before.
Can you make it bigger a bit?
Can I make it bigger? Of course I can.
Yeah.
Nice. Can you guys see better now? Just tell me quickly so you don't lose half of the presentation. So yeah, we've implemented the authorization step again to make sure that the joke can only be updated by its creator. And this signals a problem because these resolvers, the resolver here and the resolver in the query, are completely independent of each other, but they're using the same authorization step. This signals a problem that grows as your schema will grow, and I'll go into that later. The mutation result that we get here is an error where we say invalid funny level because we passed the funny level 10, and this joke isn't that funny. So suppose now that we're going to build out our schema, right? The schema has started small with a query and a mutation. Now we want to add some functionality to retrieve a list of jokes, to delete a certain joke, to create a joke, and so on and so on. Your schema will keep growing and growing and growing. And something is going to happen. We're going to get authorization and database logic all over the place. So you saw with the query and the mutation that we already have some separate authorization logic there. It's very easy when you're implementing a GraphQL API for this to like explode out of control, and you end up with a code base that's not really maintainable. And this is something that you really don't want. Some direct effects, if this happens, is that your logic will be spread around independent GraphQL resolvers that are very hard to keep in sync. So if you change the authorization step in one resolver, you need to make sure that you also update it in the other resolvers. Otherwise, you'll start getting errors in your API. Testing is very difficult because we're putting so much knowledge inside of these resolver functions together with GraphQL. We're putting everything together. Testing is very difficult when you do this. We need to tear it apart to make it more testable. And because everything is so independent of each other, it's really hard to maintain. And some long-term issues of this is that because we've added or really linked our logic so close to GraphQL, it becomes very hard to switch to another API protocol if we wish, because all the logic is intertwined with GraphQL. And another,
why would you want that?
What?
Why would you want that?
Well, of course, GraphQL is awesome. Why would you want that?
I decided to switch to core and what's on?
Yeah, I know. If Facebook comes out with something even more awesome, then maybe you want to switch. Another thing to note here is that we've really put the database logic of the specific database that we're using also in these resolver functions. So if we were to change to another database type, this would be a massive undertaking to rip apart and then put back again. So this is very dangerous. So what is the solution? Separation, of course. GraphQL.org, on the very bottom, they propose the following split, where they say you have a very thin layer, which is your GraphQL API, then you have a very big part, which is a business logic layer, which also performs the authorization, and then you have a small part underneath, the persistence layer, and they propose this split. And what you notice here is that this is a very loose layer, so if you wanted to switch it out, it would be a lot easier if we put a lot of the logic inside of the middle part. And I'll get more into how you would implement this. But first, what is the business logic responsible for? It can be the single source of truth for enforcing some business rules. So for example, we saw the authorization step that we did. This is something that has to go inside of the business logic. It determines how data is retrieved, created, and updated from the database. So yeah, it performs authorization for the data. And it also performs some validation to make sure that any input that's provided through the API conforms to the correct business rules. So we have our split now. How are we going to implement this in code? Well, instead of putting all of the logic inside of the resolver functions, we're going to map directly to the business logic. So if we go back to the query that we saw at the beginning, we wanted to retrieve a joke for ID 1. So before the split, our resolver looked like this. It was contained quite a lot of logic. After the split, it is a lot simpler. So now we're importing a joke object from our logic folder, and the resolver maps straight to the joke.gen, which is a static initializer on the joke class. It maps straight to that, and it passes the viewer and the ID that's being retrieved.
Could you go back one slide?
Yeah, sorry.
One more slide? See the difference one more.
Yeah. So we're putting all of the retrieval logic here and the authorization logic. And now, after the split, we're basically, the resolver acts directly as a tunnel that maps straight to the business logic. So this, if you wanted to take this away, it would be very easy, because there's really not a very strong connection here. How will we implement this, this joke thing in the logic? Well, very simple. It's a class called joke with a constructor called a gen, which takes in the viewer and the ID of the joke being retrieved, and it performs the authorization logic inside of this static constructor. And then the constructor takes the data that's coming straight from the database, and it wraps it in some class properties. And some things to note here is that this gen method can be called anywhere in your GraphQL schema. So if you have, like, let's say 5 locations where you want to retrieve a joke, they can all map to this gen method here, and you can make sure that you have a single source of truth for authorization. Make sure that authorization always takes place in the same way. And finally, what we're also doing here is we're wrapping our database. So if we wanted to change our database type, we would only have to update it here in the business logic layer, and we would not have to rip it apart from our GraphQL implementation. Sorry, I saw a question.
Yeah, quick question. This whole thing is about preventing overfetching?
No, this whole thing is about... Sorry, yeah.
And what I see here is that basically this is the thing that actually determines what gets returned. So you still fetch all the data.
Yeah.
This is despite of GraphQL or whatever, because that's just how data interfaces work, in my knowledge. Yeah. According to my knowledge. And here you actually map the stuff that you get returned from the database to something that you want to return to the client.
Yeah, that's right. Yeah.
So isn't that what you always do if you use GraphQL or whatever else? Maybe I've completely failed to understand the...
Yeah, so basically what I'm trying to represent here is that we're basically doing the same as we did before. We're retrieving something from the database and we're mapping it to resolver functions, like we saw before with the database. But what we want to enforce here is authorization rules. To make sure that if someone is retrieving a joke, a certain authorized user, a certain authenticated user, that we always make sure that the privacy concerns are upheld, so that we can make sure in a single location that the authorization is correct. We don't want to write that logic in all kinds of different places. We want to have it in a single location inside this class. And that's kind of what we're trying to represent here.
Yeah, I understand that, but I thought that the whole way of structuring the query in the beginning with GraphQL,
Yeah.
where you define the fields that you actually want to return,
Yeah.
that would be some kind of magic that would transfer to the database.
Yeah, well, actually, that's what you can do with the fourth parameter of resolve function, which has some meta information about your query. So out of that information, you can extract the fields that user requested, and then you can use those fields in order to make a more fine-grained like query to a database, and it will. Yeah, you can do it as well. So this is what we do, for example, for our API. So it's pretty flexible, actually.
So this is the authorization. Next, suppose now we look at the mutation to update a joke that we saw earlier. When we want to update a joke for a certain ID and the funny level, and then we want to return the ID, the text, and the funny level of this mutated joke. So again, here we have the GraphQL implementation that we saw earlier. And now we need to do something in the resolve function. So what are we going to do? We're going to perform some authorization by retrieving the joke for the joke ID. Then we're going to perform some validation and update the database in a instance method on the joke class. And you see here that the authorization that we're doing is the same as we're doing for retrieving a joke by its ID. And this really keeps the system maintainable and understandable for programmers. Because as your schema expands and you're getting more and more types, it becomes very difficult to control the beast that is authorization. And you don't want any errors to go to your client. So this is a really important lesson that we've learned, and we actually got this from best practices that Facebook has done. There's a talk from React Europe 2016 given by Dan Schaefer, where he outlines this approach, and this is also the approach that Facebook has taken with their API to make sure that all the types that they have a maintainable way of ensuring authorization.
It's mutable state, right?
Yeah. So this is the split that we proposed. And the benefits, as mentioned earlier, there's a single source of truth for enforcing business rules. It's a lot more testable now because we can really write focus tests to our business logic layer and our GraphQL layer. It's a lot more maintainable because all the complexity is controlled in a single object. And that's the first lesson. I'm going to hand it over now to Florentijn. He's going to talk about the second lesson.
Thanks, buddy. All right. So lesson number 2, we believe it's very helpful to implement a relay compliance schema. So what is a relay compliance schema? So basically, first, what is relay? A relay is a client library that is used in combination with React to communicate with your GraphQL backend. But to use relay, you need a relay compliance schema. So what is so special about this schema? Well, this GraphQL schema makes some strong assumptions about refetching, pagination, and realizing mutation predictability. In the next couple of sections, I'll give some advantages of why this is helpful. So first of all, client-side caching. So suppose we have the following query. We have a query where for the authenticated user we are retrieving the ID, and we are also retrieving his or her jokes. And for each joke we are only retrieving the ID. If you look at this result, we see a couple of things. First of all, both the ID of the viewer and the ID of the joke are equal to 1. This is actually undesirable for a couple of reasons. First of all, likely there is some database logic shown here because it's likely just the ID that is used for each database row. You don't want to show this in your result that is shown in the client. And second of all, these IDs are now the same. If you want to implement client-side caching, it's preferable to have globally unique IDs, because in this case, caching on the client side is a lot easier. So what is the solution? Well, create globally unique opaque IDs for all GraphQL objects that you return to the client. So if you now look at the same query and we look at the new result, where we have two very opaque strings, well, you cannot write any database logic around this. Well, you can only make the assumption that all database IDs are animals. But
You see it encoded in the
Sheep and monkey.
there you go. Yes, and second of all, yeah, because they are unique now, client-side caching becomes very easy. So these are the two results that I just discussed. But there's another advantage, namely that every object can easily be refetched. In a relay-compliant GraphQL schema, there's something which is called a node field, which brings us to refetching. So in a relay-compliant schema, we have the node field, and basically what it returns is an object that conforms to the node interface. And with this, you are able to refetch any object for which you have an ID. And in this case, we provide the ID Easter egg. We can just return the ID because this is in the interface. And then since we know that it is a joke that we are retrieving, we can also retrieve the title and the funniness using an inline fragment. This is how it's called in GraphQL. So yeah, this is how it works. So if you then go back to the example, we see here a...
Make it bigger.
Oh yeah, very good. Thank you. So yeah, we are retrieving a node here, and we are writing an inline fragment for both the joke and the user. But since it's the object that is retrieved from the database is a joke, you will only see the ID here, the text, and the funny level. Since it's not a user, this will not be shown. So how does this work in the back end? So basically, this ID, when the query comes in, this ID is then first split into a type and into a database ID. And then thereafter, because the type is known, you can just point to the right database table and you can then retrieve the object that corresponds to that ID. And thereafter, it's passed to GraphQL, who can then determine for each fragment whether it can return any information. And then the result will be this.
Do you secure that layer?
Sorry?
Do you secure that layer?
100%, yeah. So basically, yeah, good that you say it. You can only, of course, so basically how you secure it, every request you send to the server, how we do it, we send a bearer token and we just determine what user belongs to this bearer token, and then we set the context that Dirk talked about, and in the context we define a viewer, and then using the same authentication logic as Dirk described, we can then determine whether you can actually retrieve the object that corresponds to that ID. So yeah, a third advantage, pagination. Well, suppose you have a person that really likes storing jokes in the joke machine. Well, suppose that person stored 1,000 jokes, and that we wrote a client that wants to retrieve those 1,000 jokes. Well, you can imagine that this is not very performing very well. The backend needs to load all these items into memory. The amount of data that needs to be downloaded is quite a lot, which can be slow, and also this data needs to be processed on the client. So then why pagination? Well, pagination gives you more fine-grained control about how you retrieve this data. You can just retrieve subsets of information, which of course you want. It prevents your app from being slow, mainly because you need to download less data at once, and can also improve your backend performance. So, how is this done in a relay compliant schema? Well, if we look at this query, we are retrieving jokes, and we are specifying two arguments. The first argument is first, and the second argument after. So basically, what the author argument is, it's a cursor which specifies the position where you are in your ordered list of jokes. And then the first argument first then specifies the maximum number of items that you return. So basically what you then return is a are two fields. The first field, edges. So each joke corresponds to an edge, and for each edge we can then retrieve the cursor, which we can then use in the next query to retrieve a next collection of jokes, and we retrieve the node, which is basically just the joke here. And then we have a second argument, which is called page info, and this has a boolean has next page. Why do you want to have this? Well, suppose you have only 10 jokes, and you are requesting the first 10, then now in a single request you can immediately determine whether there are still any jokes left after this joke, while if you would not have had this has next page boolean, you would have to do a second request to the server to determine whether there are any jokes available still. So we also have a small example here. So we are again...
Make font bigger.
Yeah, very good. Very good. So some very awesome jokes again. In this case we are retrieving the first 4 jokes, and if we look at the response, we can, for each joke, also the cursor is specified, and now we can just say, well, suppose we take this cursor. So after the first 4 items, you like to grab the next page, then we can use that cursor and then retrieve the next 4, and then we see that we only have 2, and now also the has next page boolean is also set to false because there are no more items stored for this individual. So yeah, that's pagination done right. Fourth advantage is the opportunity to change to relay if you wish. We actually at our company don't use relay itself, but we use Apollo, different library, but we still find that a relay compliant GraphQL schema really helps us to get a great experience. So in a nutshell, what are the advantages, in our opinion, about for implementing a relay compliant schema? So it helps you to enforce globally unique IDs that are opaque, which makes client-side caching very easy. So with using this node field, you can query any resource that belongs to you using a single query, which is very helpful. Pagination for lists is built in. Well, it's not built in, but for example, if you're implementing it in JavaScript, you have this library called GraphQL Relay.js, and this library gives you a collection of helper functions, which makes implementing pagination a lot easier. And finally, you can switch to relay if you wish. It's a popular library, so this makes sense. So to sum up, first Dirk explained us why it is very important to make a very clear distinction between your API, in this case a GraphQL API, your business logic, and your persistence layer, with as its largest benefit realizing a single source of truth for enforcing your business logic. Lesson number 2, we believe it's very helpful to implement a relay compliant schema. Well, actually, we were a bit naive because during the preparation for our talk, we actually had 3 more lessons in mind, and we also prepared them. We kind of we timed it, and then we saw that it was a bit too much. So basically, if you feel free to talk about any of those things after the talk with us, we would love to talk about it. So basically, the authentication, how you could do server-side fetching and batching, and how you can best implement error handling in a GraphQL backend. You can reach us on Twitter anytime. That's it.